All right, let's dive into one of the biggest questions in AI today. How do we actually build an artificial intelligence that we can trust? We're going to pull back the curtain and demystify the whole process, from the first day of school to the final exam.
So let me just ask you this. How can you tell if an AI is genuinely intelligent, or if it's just gotten really, really good at faking it? I mean, you could have a model that seems perfect, but is it actually learning, or is it just cheating on the test? Here's how we're going to figure that out. We'll start with a little story about two students, a cheater and a scholar. Then we'll follow them through their study session, a few practice tests, and finally, the big final exam. It all builds up to what I like to call the golden rule. So, to get our heads around this, let's think about something we've all been through, studying for a major test. And this is where we meet our two students, the cheater and the scholar. Now, this is the perfect analogy for how an AI can learn. The cheater isn't actually learning anything. They're just memorizing the answers to the questions they've already seen. So on a practice test, they look like a total genius. But the second you give them a new question, one they haven't seen before, they completely fall apart. The scholar, though, they're focused on the concepts, the why behind it all. This is the critical difference. And in the world of machine learning, this cheating has a name. It's called overfitting. This is our #1 enemy. It's when the model gets so obsessed with the tiny details and the noise in its study material that it fails to learn the bigger picture. It's memorized the textbook, typos and all, but it can't apply that knowledge to anything new. So, how do we stop our AI from becoming a cheater?
Well, we do it by putting it on a really strict, really smart study plan. And that all starts with the study material itself. This is the training phase. We're handing the model its textbook. Okay, so here is the absolute first, most crucial step. Before we do anything else, we take all the data we have and we split it into 3 separate piles. The biggest chunk, usually around 70%, that's our textbook. The other 2 smaller piles, we lock those away for later. This 3-way split is the bedrock of building an AI you can trust. So that training set, that big 70% chunk, is the model's whole world. It's the textbook, the lectures, the homework, everything. It's going to study this data again and again and again, looking for patterns and trying to figure out how things work. But just like with a human student, you can't tell if they're really learning just by watching them read. You have to test them.
And that brings us to our next phase. It's time to give our model a little pop quiz to see if it's actually been paying attention.
This is where that second pile of data comes in, the validation set. Think of it like a practice test. We give the model a problem from this set, see how it does, and then, here's the key, we use its performance to tweak its study habits. We adjust its settings, which are called hyperparameters, to help it get better. We might do this over and over, using these quizzes to coach the model into generalizing its knowledge, not just memorizing facts.
All right, so after all the studying, all the tuning, and all those practice quizzes, it is time. The moment of truth has arrived. It is time for the final exam.
And this is the most important part of the whole process. That third pile of data we set aside at the very beginning, it's been kept in a locked vault this entire time. The model has absolutely no idea what's on this test. It is 100% new material. This is our only true, unbiased measure of how smart our model actually is.
And this is how we catch the cheater red-handed. An overfit model looks like a rock star on its training data, scoring a 99%. But the second you hit it with that unseen test set, its performance just collapses. This huge gap between the training score and the test score is the giant red flag we're looking for. A good model, a real scholar, would have scores that are much, much closer.
So this whole system, this entire process of splitting and training and testing, it all boils down to one simple, powerful, and absolutely unbreakable principle. This is the golden rule of machine learning. And here it is. You can only use the test set one time. Period. That's it. Because the second you look at the test results and say, maybe I'll go back and tweak the model a little bit, you've cheated. The model has now been exposed to the final exam, and the test is no longer a fair evaluation. You just can't trust the results anymore. Let's go back to our analogy one last time. Peeking at the test set to improve your model is exactly the same as giving a student the answer key to the final exam while they're studying. Sure, they'll ace the test, but did they learn anything? Absolutely not. You just taught them how to pass one very specific exam. So let's just recap the whole playbook. Step 1, split your data at the very beginning. Step 2, train your model using only the training textbook. Step 3, Use the validation practice quizzes to fine-tune it. And finally, step 4. At the very, very end, you perform one single final evaluation on the test set. That's it.
And why do we go through all this trouble? Why does this matter so much? Because this disciplined process is the only way to know for sure that an AI has learned a real skill instead of just memorizing a bunch of answers. This is how we build AI that can drive a car safely through an intersection it's never seen before or spot a disease on a medical scan. It is all about building trust.
So now we have a solid process for making sure the AI passes its tests honestly. But that brings up a much deeper question, doesn't it? What if the test itself, the data we're using, is biased or flawed? Who is it that tests the testers? Now that is something to think about. Thanks for tuning in.